my wife and I and our 2 children moved to Davis after I got appointed to the Energy Commission in 2012. And we had always wanted to live in the central part of Davis. It's a college town, it's very walkable, it's got a lot of amenity in the downtown area. And it's a small town, so it's very green belt oriented and bike riding oriented, very cycling specific design around town. So a property came onto the market in the kind of old part of Davis, and very few of those come on, and we were lucky enough to be able to get it. It was a really great opportunity to build the house that we wanted, and we certainly looked at rehabilitating the house, rebuilding the house, adding to it, various strategies to make it more efficient. But it was essentially a very inefficient concrete block home from the early 50s. And there really wasn't much to be done to the house to improve its performance. And so once we realized that, we thought, well, gosh, let's just maybe use the slab, use what we can, but essentially rebuild the house anew. And so that's what we did. We ended up raising the house to the ground, using most of the slab that was there, and building a new house in the house that we wanted ourselves, and it was designed and built to our own needs, and moved forward from there. So here's the threshold. Welcome. We're going to put some serious technology into this, but we're going to start simple. It's a passive house. It's got thick walls. It's got thermal mass on the slab, and it's going to have a very small energy footprint to start with. So energy efficiency is just #1 organizing principle. Great windows, great walls, and a design that's simple but very high performing. The slab itself was in good shape, and so we cut it up for the plumbing and the different systems that need to go in, the drainage. But it was in good shape, and so that was huge because that meant we didn't have to create an additional carbon footprint to pull it out and then put new concrete in for much of the house. We did end up expanding the footprint, so we put some new slab in as well. The slab is the thermal mass. That is a fundamental part of a passive house approach. And so you bring it up to temperature, it's insulated around the edges, the new parts of the slab are insulated underneath. So that thermal mass becomes a really key element of keeping the temperature stable with very little energy input. So once you get it to the temperature you want, it pretty much will stay there. I was pretty clear that I wanted a high-performing home, and I wasn't really going to compromise on that. So a core consideration was the fact that I, as commissioner, oversee Part 6 of Title 24, so the California Building Energy Efficiency Standards. And the whole building code actually is quite complex and is a large document, and it's a challenge to navigate sometimes, and we hear that often at the Energy Commission. So this was an opportunity for me to put myself through the code and go through the permitting process with the City of Davis, which is an extremely responsible building department, and walk from beginning to end through the whole California Building Code. In the next couple of weeks, we're going to be skinning the whole shell. We're going to be putting the plywood on there. And at some point, we're going to, we get that shell fully done, we're going to seal it up, and we're going to pressure test it before we put the insulation in. Make sure that we've identified any big major leaks that it has, and seal those up as we go. There's this nice sticky sealing tape that we brought a lot of to be able to do the corners and all the places where the seams between the OSB plywood and all that, to really start with a nice sealed shell, and then we insulate, we drywall, we do it all again, and along the way, we just end up with a really tight, highly efficient shell.
So we've air sealed the house using a special tape called Air Stop, trying to diminish or delete as many air changes per hour as we can through the home. When we do that, we get a way more energy efficient house.
We sealed it up, actually. We took the doors and windows and we sealed those up, and we did a blower door test. And that blower door test came out to be incredibly tight. So it was less than 0.4 air changes per hour. A typical building is more than 10 air changes per hour. And even new construction is more like 4 or 5 air changes per hour. So an order of magnitude lower infiltration of air than a typical new construction. That's key to the passive house approach. It's got the building systems that really all of California will be moving towards going forward. And the reason is in great part for energy efficiency and just the performance in terms of energy, but also there are massive benefits for indoor air quality and for just comfort in general. And we're finding that the shell, the building structure itself really doesn't have to cost more as long as these practices go into extensive use. I was extremely impressed with the city of Davis and their competence in terms of giving us answers to any questions that came up and really walking us through it and being responsive when we had questions. Certainly on the water front, the gray water piece, there are brand new regulations that the city, most cities across the state will basically have very little experience with. This valve right here controls whether the gray water from the house goes into the gray water system or whether it goes to the septic system or the sewer system rather. So the city sewer obviously is where everybody sends their gray water and their black water. We've separated those out here so that if we turn this valve, it goes into our gray water system, not the black water, only the gray water. So that's tub, showers, and sinks from the bathrooms. They go into this tank, and the tank has a sump pump in it. And when it fills up, gets 8 gallons or so in it, it turns on, and it pumps out that pipe and goes out to 2 different fields around the backyard. And so one of those fields is going to have a bunch of fruit trees in it. And the other one is the big trench that you saw, where we're going to have a bunch of water-loving plants, juncus and things like that. So it'll be a little bit of an artificial wetland that'll be sustained by gray water. And it'll be in a nice place because right next to the back porch where we'll just be able to see and appreciate all of the greenery that's functioning with gray water. So this is a 5,100 gallon rainwater catchment tank. It captures the rainwater from the southern pitch of the roof, which is about half of the roof space of the house. It sort of siphons into this thing, goes underground off the roof, and then comes back up into this. And then the overflow goes out to the front yard, actually, where it's given every opportunity to course through some weirs that we've put there. And then eventually, if everything's just too soggy and it can't take the rainwater, then it runs out into the storm drain. But we're giving the water on site every opportunity to stay on site. So this tank is filtered and then and plumbed back into the house. So it's filtered, goes through a pump, and then is pressurized back into the house where it goes into the toilets. So it's used to flush the toilets. And then it also has a cold water hookup from this rainwater tank to the laundry system too. So I can choose whether I do laundry with cold from the city or cold water from this tank. After the plumbing and the wiring, we did insulation. And so I ended up researching the heck out of this. And there are a number of technologies that sort of compete. And everybody knows about the pink bats that you sort of stick up between the studs and staple in place and move on. Those really aren't the greatest technology. They're not the best technology. They leave a lot of gaps. You have to be really, really particular about the details of that if you want a high-performing home with bats. And so I ended up going with bibs, which is a blown-in blanket, it's called. And it's a little textile you tack up against the studs, and then you spray in the insulation. It's tufted fiberglass, and it fills the cavity to make sure you have no gaps so that you really have no thermal gaps in there. So you really have highly insulated, very uniform wall. And so that throughout the exterior shell of the house, we did bibs. On the interior walls for noise abatement, we did bats, but that's much less important and not important for energy. So once we did that and got that subcontractor for insulation in and out of the house, and then we could drywall, and then they can really start to make it look like a house that's that's habitable. And once you're there, then you can start thinking about all the components that go into the house and think about the mechanical and the photovoltaic panels on the roof, instrumented such that I can detect, I can measure how much power is being generated by the solar at each moment. Once you get that out of the way, then you can really start fitting out the house. So we we bought this house in 2016. We bought the property that was there in 2016. At that point, my wife had been diagnosed with cancer, and she was very much of the mind that sustainability, walkability, neighborhood orientation, all of the just quality of life issues that come when you live in a small college town and you're near the center of activity, of economic activity, and of social and cultural activity. Leslie really wanted that, and that's really why we focused in on this property when it came up. It had all of that good neighborhood walkability, cul-de-sac, no traffic, just kind of quality of life issues near the university. We were kind of determining what we wanted to do with the house, whether we were going to do an addition or figuring out some of those details. And Leslie got sicker, and eventually she died in August of 2017. So obviously that threw a big wrench in kind of what my path forward was, my kids and I. And so we decided, and actually she, I'll tell you, she, I asked her obviously what we should do about the house, and she really wanted us to go forward with it. And she certainly understood that I was really committed to the energy and the sustainability piece of it at that point. And that sort of put some wind in my sails, let's say, to kind of push forward with the project and really focus on the sustainability pieces of it and really use it as this experience we were talking about to benefit California as part of the learning process. I think the aesthetics piece and the function piece, form and function and the beauty, kind of all of those goals for the project kind of came together. And in the context of our family and our family's evolution, it was very fulfilling, actually, in that way.